Позвольте открыть заседание Диссертационного совета по защите диссертации Ивановой Элли Валерьевны на соискание ученой степени кандидата физико-математических наук по специальности 010402 теоретическая физика на тему многопетлевой расчет критических индексов в моделях критической динамики и статики. Значит, всем присутствующим, конечно, не безинтересно узнать, что наш совет собран в соответствии с приказом Госуниверситета номер 4177/1. Вот. И в соответствии с федеральным законом номер 127 ФЗ, а также приказом номер 6821/1. Вот. Ну, значит, в соответствии я назначен председателем этого совета, я Михаил Юрьевич.
My name is Dr. Nalimov. We only have doctors here.
Значит, позвольте представить присутствующих. Значит, у нас отсутствует Андрианов Александр Андреевич.
Alexander Adrianov is absent today, but we have Nikolai Antonov, Dr. Derkachev of Steklov Institute of Mathematics, and Marianne Yurchishin is present in remote interactive mode. Represents Institute of Experimental Physics of Slovak Academy of Sciences. So he's on Skype with us. So we have 5 members of the council. We have the quorum. There is a certain procedure that we have to follow, and so we'll try to follow the procedure. And the procedure says that everyone willing to speak has to put his name on the registration sheet. So we can do this when we break for discussion. Now, to start with, let me say that the applicant submitted the following documents: an application to the rector of St. Petersburg University to admit the thesis for review and defense, a copy of master's diploma issued at St. Petersburg University, a certificate on completing a PhD course in number taking a PhD course and passing the candidates exams in history and philosophy of science, English, and theoretical physics with the following marks: excellent and good, which, since we are a review by the academic supervisor of Dr. Adjiman, and a list of 4 publications outlining the main findings of the thesis, or the articles been published in peer-reviewed scientific periodicals from the list approved by the Ministry of Education and Science of the Russian Federation, and the thesis in Russian and in English in hard copy on the rights of the manuscripts and in electronic form. All the documents comply with Article applicable regulations, and on my own behalf, let me add, so we had a preliminary defense procedure, and the conclusion of our department was positive. Have a list of documents. Now let me give the floor to the let's give the floor to the applicant. According to the new procedure, we have 15 minutes for this. But since all the council members had to read the full text of the thesis, that's okay. Thank you, dear Chairman, for your introduction. The name of my thesis is Multi-Loop Calculation Critical Indices in Critical Dynamics and Static Models, devoted to application or renormalization, a group method, and decomposition to the problems of critical dynamics and statics. Several models were considered in this paper. The static model with cubic symmetry belongs to the static model. Dynamics was represented by two models. As it is known, dynamic critical phenomena, such as phase transition, can be described by the Langevin stochastic equation, where different dynamic models, depending on the type of alpha and beta coefficients, correspond to the same static action. All the models under consideration, we are interested in finding critical indices of dynamic or static character. And let's start with the dynamic model. In all the three models, we'll find the critical indices. For example, we'll find the index mu and critical index z. Let's start with the simplest model, A, for stochastic. First of all, I must say, the model describes the behavior of an anisotropic antiferromagnetic. For this model, the alpha and beta coefficients in the Langevin equation are trivial, so it's the simplest representation of dynamic models. It's worth saying that the model has been actively studied, and our motivation to study this model, it turned out that it is suitable for the description of such new substances as multiferroids. Also, a number of computer simulations has been done, which allowed to obtain a numerical estimate of critical Z index with good accuracy. The main problem in the study of critical dynamics problem is that the calculation methods, which are well developed in statics, cannot be used directly but require significant modifications. Therefore, the progress of perturbation theory to the higher orders of magnitude is much slower than in statistics. And at the moment, a static model is already known, we're up to 7. And in our thesis, we obtained a new record-breaking 5-loop calculation, dynamic indexes. The first problem that arises when analyzing dynamic models in comparison with static models is the rapid growth in the number of diagrams. It occurs because of presence of new fields, as well as the time dependence in dynamic diagrams. This problem was successfully solved by using a new method of diagram reduction, which was developed by our research team. Another significant problem is the complexity of the numerical calculation. Since the method is based on here we don't have this opportunity, so we had to adapt the method. Let's start with the first challenge, or diagram reduction. First of all, a model based on its equivalent is a more and they are different. There's two fields. Let's in this model each and the so this is a manifestation of the property that green function generates no static analog. So phi4 does not generate phi4. So this equation can be proved by at a diagrammatic level. Let us give a simple example, a zero-loop diagram. To looking at a time integral, where E is energy is equal to propagators, and the number is energy sum. So let's record this in a new diagram. So that will be a new. This is a new technique, which corresponds to this cross section, and the phi line is phi corresponds to 1. And so let's call it the time version. So then let's on this dynamic model. So we'll get this a static analog. So thus we have demonstrated that can be reduced to static. This works only for one of the green functions. But we were more interested in critical Z index. This series is asymptotic. It's necessary to use the procedure of resumming. For such series, the technique of resumming, according to the Borel conformal, was successfully proved. So we have a 4-loop diagram and a number of dynamic models which correspond. You see how the calculation is becoming more complicated after some time versions. Yet the reduction procedure into subgroups can reduce the number of integrals need for calculation is by 4, can reduce by 4. The main advantage of reduction is that we don't need any preliminary stages of reduction, but we write a static diagram and we get the final set of reduced diagrams. This method helped us to analyze reduction. We get to calculate about 1,000 integrals. And so this was an easier task. So there was a solution to the first part of the growing number of diagrams. Yet there's a second problem. Numeric calculation is so we try to generalize. We will try to generalize static where the determinant can be recorded, and for dynamic diagrams, such form cannot be obtained because of non-trivial subintegral equations. So let's take a static analog. By some special measurements, we can generate a determinant of a dynamic diagram. So this set of substitutions that has to be done, was developed by our group. After such representation, this decomposition method, which is good because it enables us to divide it into several sectors, and then in each sector we make the necessary substitution. Here you may see an example, or such a simple form. And the main problem here is the sector decomposition is generating sectors. After we addressed both problems, we could move to the fifth order of perturbation theory. This is a record-breaking result, as I see, which calls for further resumming. And while finding the A and B coefficients, the problem was first addressed in 2005. And to improve the convergence procedure, we use additional information about the function under study. First, we used asymptotics and the value of index of biometry. So this asymptotics taken into account by adding additional multiplier to the conformal representation. Such a modification was we introduced an additional multiplier, and was proposed by 1996 by Saint Justine, suggested the information, and then they not resumming, resumming in epsilon. Where resumming is easier. We used this information to resum Z index, Z2 index. So they varied. We didn't know exact values, but optimal values were chosen, leading to the most rapid convergence of the procedure. The growing loop number. The result was compared to the numerical equation for Z index obtained from the computer simulation. Can be seen that the value is about D equals 2 and D3 is within the error. Next, we will consider one more dynamic model. As same reduction procedure can be applied not to the simplest A model, but the more complicated model E, where the Langevin equation is more complex. So it's not trivial in this equation, and should say that a number of fields, a number of emergent fields, increases to 5. The technique itself, we had 5 types of propagators and 5 types of vertices. 2 propagators similar to model A, and while the other 2 correspond to two propagators as we found, the diagram reduction method for this model works even better because by combining time versions, reduces to 0. It doesn't simplify the group of errors, but reduces to 0. So we analyzed see in the third order the number of diagrams were reduced by 10 times, which really makes us happy. So once we obtained the results, we analyzed the two-loop analysis. We found that two are struggling for stability, fight for stability. In the same, another mode is stable. So we calculate index Z will have different value. And then we found a crossover decomposition of the index up to two loops, and it showed that dynamic fixed point yet if the jump is the gap is too big. So we don't know what will happen in other orders of magnitude, but we can suppose that when we having good calculation resources, we'll be able to calculate the next order of magnitude for this model. We obtained analytical results, verified the works, compared to earlier works, and so we processed 3 loops with the reduction method, and then as mode changing occurs. So this model is based on this static model, and in this case we have 4 variants of fixed points, as the Geisenberg struggling for stability. It depends on crossover value of n. So why is this model what makes this model convenient? When we know diagram results by adding some tensor structure, we can obtain final answers, and by using the 6 loop obtained in 2016, we had decomposition, 6 loop decomposition for critical indices, static indices of this model, index such as new index or index eta, further summarized according to, and the results agree well with previous works. But as I mentioned earlier, we were more interested in critical value NC, which we calculated up to 6th more order of magnitude and resummed. If you look at this graph, so you may watch the dynamics, see the vertical, these are values, and the horizontal axis, you see the number. You may see the number of loops. And for where n equals 3, a cubic mode, system switches into a cubic mode, and this straight line shows that 7th order of magnitude probably will change the stable mode. This should be considered in the future, and thus, as a result of our work, we adjusted the method and the method of reducing diagrams, and obtained record-breaking 5-loop and 6-loop results with cubic symmetry. For the model with cubic symmetry, we present the results of our work at several international conferences. We published a number of articles. Thank you for your attention. Questions to the applicant, please. Any questions? May I ask, diagrams that you obtained as by reduction, can they be used for analytical calculations? No, they cannot. So what is the problem with these diagrams? As in this case, we have only one multiplier of fifth order. We have 5 or 4 multipliers, and we cannot reduce. But still, there is a part that is not suitable for direct integration. The peculiarity of the structure of the model. Using Fein formulas. So yes, we started. So of course, we tried all this using Feynman formula. We used reduced diagrams and calculate sector decomposition. And while in the static model we could obtain analytical results, here we could obtain analytical results in simple models. Is there any explanation? Do you have an explanation for this? Is it because there is no symmetry? Yes, on the one hand, we made the diagrams more simple, yet. So it's better to have 200 diagrams rather than 1,000 diagrams. More questions? Do we have more questions? Am I right in thinking when you simplify some of diagrams, each diagram becomes, there's a reduction. You reduce most complicated diagrams. Just 1 second. And this reduction, with this reduction, you get an answer. This is the impression that I got. So the sum of diagrams becomes more complicated. Yes, each diagram we consider independently has more complicated structure. The form itself, the form of reduced diagrams is simpler, but in some cases, but not in every case. Do we have more questions? More questions to the applicant? If no one has more questions, let us move to hear the reviews of the members of the Dissertation Council. Give the floor to Dr. Antonov. Thank you. I submitted a detailed review. I will not read the entire review and will not repeat what was said before. About the contents of the thesis, I'll only read what I find interesting. The thesis is dedicated to calculation of diagrams in the perturbation static and dynamics, and finding critical indices and summing reductions. A well-known method, epsilon decomposition, is used here. But as we well know, parameters decomposition, there are many parameters, and the lines are asymptotic. Therefore, in order to obtain reliable numerical prediction, it's necessary to find as many members of epsilon decomposition as possible. Secondly, to perform some summation procedure. So these are the two key themes of the thesis. In recent years, this field of research has been became very popular again after many years of silence. Maybe in 1980s, scientists obtained record-breaking results for static, such as epsilon the fifth, and for dynamic, this is epsilon third order, and so these records lasted for some years. But since then, new, more powerful methods were developed, methods of diagram calculation. And after some period of time, the methods reached maturity. There are 6 or 7 loop results in static, and even better results in dynamic models. So this work is, the subject theme of this work is very relevant. So this Speaking of results, what I would like looks at the model of critical behavior C4 type with hypercubic symmetry or cubic symmetry. She found the necessary renormalization functions and critical indices summed up by Borel conformal method. And well, this method has a specific feature. It has 3 non-trivial fixed points, and which one is defines behavior, critical behavior of the system, depends on the number of components as order parameters. And there is a number of fixed points, the behavior changes. And while the peculiarity is that this critical value is close to the most interesting physical case, n equals 3. And from the second, third order results of the we cannot say that n is more or less than 3. It proves very consistently that a critical value is less than 3 and more than 2, and thus the critical behavior of physically most interesting situations is can be described by different types of fixed points. So that's if they speak of critical statics. So if we speak of dynamic diagrams, have more models which are less well studied. So practical calculations for dynamic models, they fell behind. And in this work, in addition to dynamic diagrams, is sector decomposition. The author uses sector decomposition method, which proved efficient. And the method is very popular diagram reduction method, which was earlier used only occasionally. And so now it became a system. And this method is based on some correspondences between green functions and can be used to unite entire class in dynamic diagrams into a single diagram. And this enabled the author to find the critical index for model A behavior, the 5-loop approximation. Also, the author obtained results for model E, obtained some value for it, and shows that to solve this problem is necessary to switch to 3-loop approximation, and some important steps were taken in this direction. And speaking of Borel method, the summation method with the help of Borel conformal method was used here when dealing with complex models, and demonstrates its accuracy. Beta convergence. So this is very interesting, even as far as methodology goes. The thesis is very concise and well written, describes in details, contains many examples of multifunctional diagrams, which makes the thesis a valuable piece of writing in addition to its scientific value. So this is a comprehensive scientific study, and the results will be valuable and can be used for future research. I don't have any comments, only small on the contents. There are some inaccuracies in the text. I will not mention all of them. for example, a term, fixed point occur together, even within one paragraph. So it would be appropriate to, because these are two different fixed, so it will be good to explain the multiplicative renormalizability of the cubic model. There are also some misprints in bibliography, so which does not, of course, affect the overall evaluation of the thesis. And I wish the author to continue her research in this field, in this sphere, because now she's very close to world-level research. She has impressive experience, and there are many interesting tasks, problems. So I hope the applicant will continue her research. So to sum it up, let me say that the thesis by Ella Ivanova meets the main requirements established by the order, on the order of awarding academic degrees at St. Petersburg University, and the applicant deserves to be awarded the degree of candidate of sciences, physics, in specialty 01040 for theoretical physics. So that's all I wanted to say. Thank you. Now, Dr. Bismarck. Let's give the floor to Dr. Bismarck. I apologize. Can you hear us? Okay. Well, let's continue our session. We have 10 minutes limit for each speaker. Maybe you don't have to read the entire review. Maybe so it's quite detailed review. And so what I did not include in my review is that the significance of this thesis cannot be overestimated in theoretical physics. In theoretical physics, the researcher has to obtain certain functions and then compared with the experiment results can be. So it's usually this is a very difficult task, and some believe that this is like, so we always talk about records here, Guinness Book records, so maybe, and in this thesis some records have been described, and what makes this thesis even more important than breaking records, the author noticed some unique features of the theory. For example, diagram reduction. If we don't do this, we cannot make any calculations. With each new step is new technology, calls for new technology. And well, here we are. There are many examples of new technology. So this is very high quality thesis. And maybe that's all I have to say. What I would like to say here is I have some comments. So let me read my comment. Among the main points as set forth for defense is sectors of critical, but in the text the procedure is not describe the procedure used to identify sectors, which in which the problems or dynamics is more complicated. But this comment is not fundamental, does not affect the overall high opinion. Is a complete original scientific study. The results and methods developed in it can be used in further studies in the theory of critical behavior. And I think I have to read the final paragraph. The thesis by Ella Ivanova, multi-loop calculation of critical indices in the models of critical dynamics and statics, corresponds to the basic requirements established by the order of 2016 on the order of awarding academic degrees at St. Petersburg University. And the applicant, Ella Ivanova, deserves to be awarded the degree of candidate of physics and mathematics, specialty 010402, theoretical physics. Clause 11 of the above mentioned order has not been violated. So this is all I wanted, this is all I have to say. And let me explain this clause 11 is about plagiarism, but all the anti-plagiarism systems are now, they don't work on physics. And let me give the floor to Dr. Derkachev. Maybe I will not read my entire review, not to take your time. Let me list some points which impressed me most. I think the results actually exceed the candidate's thesis level, and it's very seldom that we see works of such high quality. I was very impressed by the calculations technique. My graduation thesis was in the same field, so I know how this works, and I was very impressed that you managed to break through the entire order in my time, a record result by Antonov Vasiliev. And well, how you managed to do this, I admire your work. The reduction method, maybe many people noticed that in the sum of diagrams is reduced and it becomes easier. So you put this into a system, and then I read your thesis and I enjoyed reading. It's very well written, very concise, all the methods described very clearly, and so you get very good understanding, and you can use your methods after reading your thesis. So maybe I listed all the points that impressed me. And as for critical comments, I only have one comment. When looking at the model with Zinga, my comment is you could have taken your results and with accidental additions. Well, basically that's all. And I think this thesis meets the requirements. And let me read the final paragraph, please. The thesis by Ivanova Ella, topic multi-loop calculation, meets the basic requirements established by the order on awarding degrees at St. Petersburg University, and the applicant deserves to be awarded the degree of candidate of physics and mathematics, specialty 010402, theoretical physics. Thank you, Dr. Derkachev. Now let us give the floor to Marian Jurčishin of Institute of Experimental Physics of Slovak Academy of Sciences. Good afternoon. Maybe I will not read my entire review because many good words have already been said here today, and all the results were non-trivial results, and the quality and the quality of the work is very high. As for me, the very fact that you managed to calculate indices 5 and 6 of order of magnitude, that's amazing. That's very difficult, hard to obtain such results, and the use of technical methods which were summarized and used to explore dynamic models, the non-trivial results that you have obtained. As for me personally, I have only a very small number of comments. I don't know if I should read all the comments, but there are some you have some misprints in the text of your thesis, which of course do not affect the level of your. I had 2 questions actually, and then on the other hand, I would like that it would be good to see more discussion in your, because all the results are based on these non-trivial questions. So my first question is, let me read it in English. Здесь возникает следующий вопрос. Какие ли результаты были получены при помощи, будут ли результаты такие же? This is my first question, which maybe needs a little bit more discussion. And my second question. В процедуре возобновления на странице 63 предполагается специальная форма асимптотического поведения, которая приведена в... So these 2 questions, I would like you to answer these 2 questions. Maybe well, you should dwell a little bit more on these 2 points in your thesis. And однако указанные выше недостатки не снимают общего качества, высокого качества работы. И, по сути, диссертационная работа представляет собой шедевр теоретической работы с большим количеством нетривиальных результатов, полученных с использованием сложных теоретических методов. Таким образом, диссертационное исследование, проведенное Эллой Ивановой, заслуживает представленное для искания степени кандидата физико-математического. On my behalf, that's it. Thank you. That's all I wanted to say. Now, I have to read the review submitted by Dr. Adrianov, who is not with us today, and my own review. So I will not read the entire text. The review of Professor Adrianov says that the thesis covers 3 main technical approaches. First suggested by Ivanov, but so these techniques, these methods have already been discussed here, such as reduction, sector decomposition, and Borel summation. Also, the author lists the dissertation is well written, which is good, quite clear and concise. Speaking of critical comments, some inaccuracies in the list of reference literature, and summation is precise. The choice of fit parameters is obtained by 0. So it will be good to set forth the mathematical criteria for the choice of such selection. But of course, the thesis by Ella Ivanova meets the requirements, and the applicant deserves to be awarded the degree of candidate of physics and mathematics, and clause 11 of the said order has not been violated. This was a review by Dr. Adrianov, and then, well, finally, I have my own review since I'm the chairman, and I don't have. There's no point in me reading. I don't have much more to say, to add to what was said by my colleagues. The author obtained record-breaking results in her work, and the thesis describes excellent methods which enabled the author to obtain these excellent results. And these methods are now being used by other researchers, and from that point I enjoyed the part on dynamics and diagram reduction. Yet I have some critical comments. Third comment is about misprints, so which is maybe not so important. My second comment is that I heard what the previous speaker just said. My comment is that thesis you can include more material in your thesis than in an article, and this is an advantage because you can find the thesis now on the internet, and so sometimes it says that results are available. And my second comment is even for value of for the dynamic model. You have 5 orders, and to obtain this order for when n equals 2, I have to use reference literature, and so I had to refer to my own work, which I wrote 10 years ago. So maybe these were the most accurate results, but these are my comments. And the final part of my review is the same. The thesis complies, and the author deserves. Everything is perfect. Thank you. Now we shall give the floor to the applicant, and not more. She should please spend not more than. Thank you for your comments, and let me use my slides, and I'll try to be quick. First of all, I agree with the comments on misprints. I will try to be more careful in the future. Speaking of comment on Dr. Adrianov, we did not define clearly the criteria. Yes, that's true, and in the future we will. We selected criteria, and now we are working on an article where it will be how the criteria was chosen. We'll explain. And speaking of Dr. Antonov's criticism, is not about will omit misprints. And speaking of the cubic model. Is used when one of the lines equals 0, is constant, is coincide with the model phi4. I think, well, yeah, I should have said so in my thesis. And a comment by Dr. Derkachev: if we use the model with cubic symmetry, we can also calculate the model with accidental add-ons. So our article is now, we are now preparing an article on this, and since I did not take part in this article, in writing this article, I did not include it in my thesis. There was a comment was in the sector decomposition method, which was changed. The procedure for writing the sectors was not very clearly described. The sector decomposition method, you need 2 stages, which I describe in my thesis. I should have described it in more detail. So this is a little unusual. And now let me answer comments by Marine Yurchishin. First one deals with misprints, and of course I agree. And the second, the other two comments. I defined resummation for a model with cubic symmetry, but then there is an article which has different with different results because the article was we made some changes in the resummation, and I did not take part in this in writing this article. Speaking of the choice of asymptotic for a model, the choice was this was a complicated task which I did not explore. Back in 2005, some authors obtained the coefficients, and so in this case and that is why I did not describe in detail. And comment by Dr. Nalimov. There are some results are missing in my work, which have been published been included in the articles. So some of the results there is in the article. I refer to a file which is accessible. So that is why I did not include this results in my thesis. And speaking of missing values when n equals 2, since my thesis was main focus was on abstract n value, maybe in the article it should be included. The results for different n values should be included, and only for n index. And because we compared with computer modeling where n equals 1, the result of resummation result, I think maybe we should have included other n values in our results. Thank you. Are all the council members satisfied with the answers? Next, does anyone present at this session is not a member of the Dissertation Council want to speak? Do we have any volunteers? Mikhail Kompanets of St. Petersburg University. As a co-author of most articles, Ella, we worked very closely together, and I had no reasons to criticize Ella. Maybe she was sometimes too slow, but in the end, we managed to overcome this issue, and I am very satisfied with Ella's work and the results. A big part of the results presented here. It was our joint. We worked together, but some of the results belong to the author's Ella, the reduction that we described here already, we discussed here today. So this is her brainchild. So maybe that's all I have to say. Thank you, Dr. Kompanets. Does anyone else want to speak? Since next item is general comments of the applicant, do we want to add something? Maybe not at this point. Okay, now let's give the floor to the the thesis is a continuation of a series of record-breaking results obtained at the Department of Physics. There are two sets of record-breaking results, two models of the three-loop model, analytical result is obtained by Dr. Antonov and Dr. Vasiliev. Then recent record of Nikolai Kampanets is a six-loop in the phi-4 theory, and one of the authors, Ella Ivanova, is also Alexander Sokolov. He made some multi-loop calculations dedicated to models with complex symmetry. And here the records set by the applicant continue the tradition of setting records of the university. And well, the value of her results is obvious. I think it's very important that she's created the basis for calculation of dynamic models, and in this diagram reduction plays a major role in this, which achieved through active interaction with Dr. Kampanets. So that's very important, and gives us reasons to hope for many new dynamic models will be described in the future, and with the help of sector division into sectors, breaking into sectors. Well, basically, that's all. Thank you. Does anyone want to say something? Anyone else? If no, you may, of course, you may ask questions. May I ask a question? Did you try to end decomposition? The reduction method should be efficient, dynamic. Are we talking about dynamic? The dynamic model? No, I did not. No, we haven't done that yet. Well, and decomposition, we have not even started on this work. Okay, thank you. And next item on our agenda is discussion of the by the council members. For that period, broadcasting, online broadcasting should be suspended. So please. Please start broadcasting again. Are we on air? Very well. Yes, we are. Very well. Let's start the open voting. Now I put forward awarding the academic degree to the open individual vote. And of course we need at least a half, but not less than 3 members of the council. Dear council members, stand up, please stand up and give your opinions. Dr. Antonov, I am for awarding the degree. Dr. Bismarck, yes, I support awarding the degree. And Dr. Derkachev, I support awarding the degrees. And Dr. Yurchishin, yes, I am definitely for awarding the degree. And myself as the chairman, Dr. Nalimov. So we have 5 members of the council voted for awarding the degree. No one abstained and no one voted against awarding the degree. Thus, the decision to award the degree Ella Ivanova, the degree of candidate of physics and mathematics, specialty 010402, theoretical physics, has been passed. And let's give the floor to the applicant. Thank you, everyone. I'd like to thank everyone present, and especially members of the Dissertation Council, for finding time and agreeing to take part in the council. And I would like to thank my scientific advisor for the good discussions, for his guidance. I'd like to thank Dr. Campanese for our good cooperation and interesting discussions of our tasks. And I would like to thank my entire group and my department and my parents, my family, for their support and for their patience. Thank you, everybody. Thank you, Ella. Our meeting is closed. Thank you for your participation.